There's more value in the connections outside of these talks than actually listening to the talks themselves. We've spoken to a lot of very experienced, very tenured people who have lots of, great stories and mistakes that we can learn from so that we don't have to make them as well.
Hello everyone, and welcome here. The talk about monadic operations. And today we are going to talk about practical approach to this technique. Let me introduce myself first. My name is Vitaly, and I've been doing C++ for quite a while. So more than 10 years of experience in developing different things, from the framework libraries to VFX and geospatial systems. And now I'm working as a senior software engineer at Remarkable. We are a Norwegian company, and our main product is this nice ink tablet for those who making notes, sketches, diagrams, and stuff like that. I'll be happy to share more, but after talk, it's not the main point here. And as an agenda for today, we are going to briefly talk about two classes with monadic operations support. The first one is optional, and the second one is expected. This talk is mostly about expecting its monadical operations. Then we are going to talk briefly about common use cases and tips and tricks at the end. I'm not going to talk about any theory here, not even about category theory. There will be examples from the C++ only, no Haskell or any other functional languages. And I will be showing a lot of practical examples here. So you can ask questions during the talk, and I will probably ask you to raise your hand a few times. There will be some questions to you. And I also put 10, 15 minutes aside at the end of the talk for questions, if it's more comfortable for you. So let's get started. First of all, I already mentioned 2-3 times the examples and where do the examples come from. We have our own internal framework that we use for development on our devices. And from the very high perspective of view, there are 3 main components that we have: libraries, that's basically shared functionality, then modules. They represent the certain capabilities, like say, for instance, the last generation of our device may support the colorful display or the pluggable keyboard or something like that. And when we combine those modules all together, we get in bundles right here. And those bundles, they do represent the certain piece of software. For instance, we have the previous generation software. Then we have the desktop emulator if you don't want to test everything on the device, and so on and so forth. In this framework, we have a lot of different subsystems, and one of the most interesting, perhaps, subsystem is the user interface subsystem. That's responsible for primarily collecting windows and widgets from modules, and windows mostly in terms of mobile development, not like an operating system windows, and widget that the small parts that the modules can share between each other to display some piece of information, like settings, for example. We use, of course, we do not render it ourselves. We use bindings to some third-party libraries, and for the devices that are Qt library. And this module also used for navigation between windows. Say we want to open a certain window or a certain route, that module will be used for this. Okay, now my question is, how many of you are familiar with Qt? All right, I will briefly talk about it then. First of all, the technologies we use, it's also an interesting part. So we use C++20 for our product. We have VC package as a package manager. So we have 30 plus different third-party libraries in use, like ranges, TL expected, Cage2 for tests, and many other stuff. And as I mentioned, Qt for UI on the devices. Qt, the interesting thing, it kind of has 2 words. The first word is the word of C++ code. And in this word, we define our business logic, do integration with third-party libraries, some system level or say non-cross-platform abstraction. And on the another side, here we have QML code, and QML is a declarative language that's used to describe the UI. And in this code, there also can be some logic, say animation related, states related, and so on and so forth. And there is a connection between all of those two stuff, because from C++ code, you can create QML objects and manipulate QML objects. And from QML objects, you can use C++ objects that are exposed some way. And this is interesting. That was one of the motivations why I decided to talk about this specific system, because the error handling, the approach to how we work with the code, the paradigms are completely different. In QML, for instance, it's completely normal to, say, just print all errors, warnings, and stuff in the user output, the default one. Whereas in C++, we can do monadics, we can throw exceptions, and error codes, and many other things. Now let's talk about classes, optional and expected. There were many good talks during the conference, so I will just not dive deep into it, just talk very briefly. The first thing is std optional. The closest abstraction, or we can think about it like about pair of certain type and bool, which is not like this in all implementations, but still it's easy to understand. And this stuff can contain either value or nothing. Here we have optional box of int. I will be using this technology because, well, for many reasons, but it's super easy to visualize it as a box where you can put something and there'll be something or nothing. And now we put in this box 42, and then we can extract this value from the box like this. We usually use optional when an operation can fail, but we don't care why. For instance, here is an example of some vector class, and it supports separation index of. If element is not found, we simply return special object std null opt that indicates the absence of object of the result, and if the element is here, we can return its index. So in this particular case, we just don't care, okay, or there is only perhaps one reason why index of returns something else than in index, right? There is no element in the vector. From time to time, I don't like this one in particular, but I saw it many times. They use optional to pass some additional arguments, like for instance, here we have a function to resolve URL, and then we have optional configuration. If there is a configuration, we can resolve a URL from the raw input accordingly. Or if there are no configuration, we resolve it using some default settings. And yeah, from C++26 or probably the next standard, the optional will be iterable. It will be range view, but with a difference if you read the last sentence here. So it's kind of the lifetime of contained element bound to the object or to this range. And it's kind of interesting stuff. We will see how to use it when it will be in place, because there can be a range of either 0 element or 1 element. So interesting thing. So now let's talk about expected. And expected is very similar in a way, with the difference that there can be either object of T or object of E, so left or right. And the closest implementation would be std variant, target union of T or E. And if you have expected box here, for instance, of int and some error class, because in C++ we think about it like the first one is a value and the second is an error type. And we can put something here. Now it's value by default. To put an error, you should use unexpected. I will show you later how. And then we can extract it from the box. When do we use it? And we use it when an operation can fail, and we potentially want to know why. For instance, here we have a function for loading a widget. We have stood expected of widget itself, some control structure or handle, and the error, why it can fail. So if it's an error, we return stood unexpected of the error. We have to wrap it. And if we want to return an actual result, we just return it, and expected will be constructed of it. So it works exactly this way. Where you can get it in standard library and the monadic operation support from the C++23 standard, if I'm not mistaken, or you can use TL expected and optional as well via Conan or VC package sent to all contributors. That library is very good and mature. And the question now to the audience, if you use expected in your project, where it comes from standard library or from something else? All right, yeah. More people using something else like TL presumably or own implementation. We use TL as well in our project. And there is there are differences, some minor differences between student TL expected, TL in more relaxed in a way. I will show you some examples why, but the main issue or the main motivation why would you use the third-party implementation is that your tool chain might not be new enough. For instance, we have mobile tool chains and they do not support stud library of the version we need for all monadic operations and expected. Now let's talk about use cases and what do we use. In most of the cases, like I do not have representative statistics for you, but we mostly use expected, mostly use it for error handling, and from time to time for interface unification. I will tell you what I mean a little bit later, but basically it's for having interfaces that you can chain or compose on. How do we usually process stood expected? You can read this example. There we somehow get a new widget and it returns expected widget box. We check in whether this is a value or not. Here we can technically omit this stuff, but I will be using more wordy code for better readability on the slides. So then here we know that there is a value. We extracting this value, taking it out of the box, and doing something with this widget. And otherwise, we just working somehow with an error. We, for instance, can print an error here. Now, if you think that this example is kind of wordy, and whatnot, please read this one. And once you read it, you can tell me what's wrong here. All right, I already see the correct answer, and the issue is right here. So this example, as all other examples, are quite reduced, I'd say, but in a real code, you can get your widget box, then have some code here, and then all of a sudden, you're trying to handle your error, and then you think, okay, that would be a good idea to print something that in the widget box. And you completely forgot, or you just don't pay too much attention that there is nothing in the widget box, like there is an error, there is no value. What would happen in this case, the exception will be thrown. It's not something you really want to have. And surprisingly, this error can be not spotted immediately, because even if you cover with a test, from time to time people do not cover negative scenarios, don't do fuzzing, don't use tooling and whatnot, and such issues can be caught super close to production builds or release, if not in the production, which is not something probably you want to have. How can we handle this? And there, where we can start talking about monadic operations. So how many of you ever used monadic operations in production code? All right, that's good. So not many. But again, I will not explain it deep into details here. just for regular monadic operations with some practical examples. And I would recommend you to watch like another talk from this CppCon or from previous one if you want to have these tables and have better understanding of those stuff. The next 4 slides, they have 2 parts. The topmost part is procedural code, and the bottom one is analog with the monadic operations. So that's the same code. We are getting widgets somehow. Assume that's identical function, get new widget and get widget. And here, and then we pass in a lambda function or a free function here that accepts widget and the returns expected of widget or widget error. And the main point here is that here we have not expected, we have widget itself. And this function that you pass to and then will be invoked only and only if the object returned from getValue contained the actual value, so not an error. So that would be invoked only here if this, in this part. There are some limitations for this function that you return stood expected, and you can technically alter this type, but the error type should be the same, and this function must return expected. So then you do something and with a widget, and then you can return the widget. And the good thing about it here, that you don't even have the technical ability to say call error, or in this case it would be error, basically because there is no expected. You're working only with the widget itself. The value is already unwrapped or taken from the box for you, which is very good. Another rather similar function, say when you need to not only work with the value, but to transform, to turn it into something else. And here we want to just take widget ID. Here specifically we have in widget ID. And then to the transform function, we are passing the lambda that returns ID as well, and then returns widget ID. So from this function, you do not need to return expected. You can return just a regular value, and then this value will be wrapped for you into the proper type. So that would be basically expected of ID and widget error. And again, I want to highlight that this function will be called only and only if the object returned by getWidget contains the value, not an error. So there is also a regular widget, not a widget box, not an expected stuff. Also good thing. We have another operation or else, and this operation corresponds to the second branch, to the else. So we can have the chain, and then do something or else do something else. And there is, you should pass a lambda, then accept an error. And the error is, say, in this particular case, widget error. And this function will be invoked only and only the value that returns from, say, getWidget, and then it passed by, and then it ends up here, only and only if it contains an error. So you cannot, say, invoke value here. And that's where TL and stud slightly diverge, because in the standard library implementation, this function must return expected as well. And then in TL, it's slightly relaxed. There is the specialization for void, and you can do it like this. So for instance, if you want to do something with, or else somehow finalize, print, log, whatever, you can use it. And you don't have to return anything. You can do it just like this. This very small difference, but just keep it in mind, please. Another super useful function, we get back to it a little bit later as well, but the same way you can transform the value, you can transform an error as well. And this function is used basically to change the type of an error. Like here, for instance, we transform in the widget error to string somehow, and here we are doing the same if there is an error. Any questions about like basic of Monadic so far? Yes, please shoot.
I just want to add a comment on like another benefit. Everybody care about using this monadic functionality is about performance. Like this is not only more correct way of using expected, but it's also more performance because, like for example, if you use transform, the return value will be directly constructed in place instead of like using move semantics if you like do not properly like if you do not create a local variable then use not guaranteed lambda return value optimization. So it's not only more correct, it's also more performant.
Yeah, thank you. That's a great comment about performance. Like say, if you have concern, I agree that many things are created in place, many things are moved between, there is return value optimization involved, but like if you have any concerns, please profile, take measurements for your real apps, for your real cases, for your real scenarios. It's always like that. Do not trust if anyone tells you like that's something is performant. I'm not telling that we shouldn't trust you because it's correct, but yeah, so you should measure. And now we are getting closer to point, to the software development itself. And there are three key parts or three pillars about practicalities of using those monadic operations. So, and we will start with people, then talk a little bit about design and how we can turn our procedural or object-oriented code into something more functional. And let's start with people because it's the most important stuff. If you have like misunderstanding around or you have significant resistance in your project, in your team, you will never, ever be using any kind of monadic operations or new things. It's super important to like be on the same wavelength with all of your team. But before we start talking about like people and things, so there is an example. Please read carefully. And this is because you're left or right, but who thinks that the procedural code, this one, is better by any significant criteria for your readability, maintainability, safety, and whatnot? Please raise your hand. This one. 0 hands. I'm happy talk is over. But yeah, so who thinks that the right one is better? Right for me, left for you. Cool. So, and this is the main point. Many even experienced engineers I had a chat with, they answered me, okay, fine, this code is easy to read. I don't need to care, I don't need to know about some abstractions, what transform, what do I pass here, so how it works, how it passes, how it constructed, so what the level of indirections here and whatnot. And you need to spend some time to convince, to just talk, to show practicalities. And because of that, like, you should realize that the functional programming itself is like, it's difficult for many people. It's not something straightforward, right? And even if we are not talking about the functional programming itself, like the pure functional programming, if you name it this way. So even if you're talking about monadic operations or just function composing, or even if we start talking about expected or optional, it's terra incognita for many. You should have like this assumption in mind when you're trying to, like, for instance, return to the company, to your company from this talk and starting to share, starting to talk about monadics and so on. What you need to do, you need to show practical benefits of this. Like, say, you can create less boilerplate code, you can make your code more performant, with of course all measurements taken, that you can make it more safe in terms of like more predictable, more deterministic in comparison to exceptions thrown from random parts of your program and whatnot. Then you better, it's from my practical experience, do some workshops where you can let people to play with this, to give them transform some parts of the code to these monadic operations, even from the real project. That's super beneficial. And then the last part is a design review. If you, in your company, do you have design reviews in your company before like kicking off feature or something like that? Great. So this is a right place if you invite it to just share inspiration, to say, okay, what if we say start using Monadic separation in this particular interface? What if not? And just it can be like too low level, but it's a nice place to bring it up. Now, assume people are convinced you want to use it. Let's talk about design. And another thing you should accept, you will never ever be doing purely functional programming at all, unless like very teeny tiny chances when you're doing open source with a small group of enthusiasts and so on, and perhaps another language. But in practical programs, in enterprise programs, there always will be some side effects. There will be object-oriented style code. There will be parts of existing code base, most likely. There will be integration with third-party libraries, and many of them are not in functional style at all. And many, many other difficulties in your way. So there will be no purely functional programming for us, unfortunately. What we can do, though, is try splitting the code, the functional code or code with Monadic or a certain code, and another parts of your app. The parts can probably, well, have some login output, some UI interaction, some integration with another libraries and whatnot. From the parts where it perhaps doesn't make much sense to make them functional, it will be just too much effort, or your technologies doesn't support it, or it just doesn't make sense at all. So you need to have like very clean boundary between those stuff. And this boundary, it can be like on the class interface. I'm telling the class here because we mostly do object-oriented programming. So, and your interfaces can return objects of expected or optional. And that's pretty much it. It can be transformed, of course, with a set of the free functions later and the state that you pass between them. But still, or it can be the library interface itself. So that the highly coherent set of classes, right? I have an example from our project. In the UI subsystem I mentioned, yeah, okay, it's good. So what we have here, we have class for managing window layout, and it's an interface, and this is the window layout stack. It's how you can manage window, like the new windows appear like over the previous one, the classical order. And this is the implementation in C++. This one is also implemented in C++, but this object will be exposed for QML, for Qt code. And there is a boundary I put here. So that's where we can do our all functional magic, monadic magic, have functions without side effect, referential transparency, whatnot. And here you can just follow the rules of the another parts of the program. Say we can, for instance, print an error to the standard output. Let's start with the interface class. And there is a window layout class with only one operation so far. For adding window, we add in windows by URI somehow. Then we return expected. Core expected is an alias for the certain part of library for expected with certain error type. And we have void as a default. That's why we can omit type here. It's also a very good practice if you have, I didn't mention it specifically, but if you have the certain expected type per, say, library or module, call it whatever, that's a very good practice. And this is how certain implementation can look like of the Windows stack layout. Again, implementation is reduced and a little bit simplified. So what we do, we load window from URI with some object for loading. Then we adding it to layout, updating active window, and if there is some error, we add in certain prefix for the error because we want to like track where this error happened to understand that this error happened at the Windows stack layout. And that's how you can code look like inside. So composition of function, and then you can return because of the interface also has expected object. Then you have this wrapper. That's exactly boundary. We inherit, I will just briefly tell about Qt machinery because there were not too many hands about Qt. So to expose an object for QML, to inject it, you need to inherit from special object in Qt, QObject. Then you need to use special macro that's to inject some metadata. And the properties, they act like normal properties in many other languages. There are getter, setter, and notifier when property change. And all of those stuff are just regular methods. It refers to regular methods in the class. And then inside, as a private field, you have the layout, the implementation. And basically all operation comes through this stuff. It's a very teeny tiny wrapper over it. When we want to add, when we want to invoke the regular implementation, what we do, we just check in the object, add in window, but or else here. That's just prints an error. We clearly have side effect here. That will be printed to the standard output, but that's the way they handle errors in QML. So do we. So there is a boundary where we don't have to follow any kind of functional things anymore. We just do side effects here. So and this is very good because we can integrate our monadics and things within the existing code base almost painless. We have the interface on which we can compose already. And we have clear separation from functional and functional code because there still might be like developers from other departments who are responsible for other libraries. They don't want to deal with all of this complicated functional thing, and which is also very good at the beginning. Now I'm going to talk about small steps, and those small steps are basically about how we can do refactoring, or if we are not talking about refactoring, about new functionality, if it's simply for you to write everything in procedural style or object-oriented first, and then port locally to the monadic operation. We are assuming that you have object-oriented style code base. I guess most of us do. We'll not asking. So then we start like not from the top, but like in the sort of functional programming paradigm, we do it like from the bottom to the top. We start with the small pieces and then combine, and then getting the result. We start from the implementation of the methods themselves. Then we partially change interfaces of the classes. Then we fully change class interface, and potentially, if you like enough, we can drop classes fully. And how we can do that? Say we had the object-oriented interface here. That function used the first function I showed you in one of the previous slides for the layout for loading window. It now accepts some window URI and the loader class for loading stuff, and returns loaded window as a shared pointer. And then we had, suppose, old interface that returns bool, that when window is loaded, it's true, otherwise it's false. If the window is loaded, we do something with it, doesn't matter what. And then if it's not loaded, we return false. So I guess many of you have the code like this, source code like this in object-oriented style. What can we do first? First, in the simplest and smallest part, what we can do, we change in the return type of this function of the load window. And we just put expected around the type. That can be your expected. I already told what this means. So you don't even have to touch interfaces at this step. What you do, you already can chain. You do load window, then you can already, and then you can add to layout, and you can do much more things, and then you have result. But result is kind of useless right now because we just checking if it has value. Then suppose the window is loaded correctly, and we simply convert it to bool. Otherwise, we just forgot about all errors and stuff. We have nothing here. But we're already one step closer to move it into the interface. So that's the last step, or like most likely this step will be last. We change in the interface, and there is now not many things to change at all. We changed the return type. Perhaps we need to do an then, transform, whatnot here, but we simply can return the result of the chain of the actions. And that's pretty much it. That's how you can do this from the bottom to the top. It's not necessary to be in a single commit or like, say, in single pull request. It can be just done gradually, but it's of course nice if you have luxury to change it at once. Now let's talk about practical tips and tricks. I have around 6 or something. And first of all, we should talk about some assumptions so that you are most likely in the beginning of your journey right now, and there are not too many well-defined practices in your project. And there are not too many third-party functional programming libraries are used in your project, but even if you already heavily use Monadic operators in your project, you will still perhaps learn something cool from those tips and tricks. And my first tip, surprisingly, but in functional programming, I would advise use less lambda functions under certain conditions. So lambdas in C++, super powerful tool, like perhaps the most flexible I've ever seen in any languages. However, it comes with a noisy syntax and some capture list that's, strictly speaking, a food gun. So how many of you ever had any issues with the lifetime of what you captured? Yeah, so especially if you use Qt or some other stuff, there are event loop, there are like kind of asynchronous big coroutine that jump in between stuff and whatnot. So that can be here, and this is like a big full gun, but it's not the thing why I would advise against using lambdas. Lambdas are cool, powerful. If you have a small lambdas, like one line, use it. No captures, like no lifetime synchronization, use it, please. However, if you have a lot of nested lambda functions, like a callback hell or whatever, if you ever think this like, you know, big stairs of lambda functions that cannot even fit your screen and you just suffer instead of coding more than necessary, so then it's not good. If you have long lambda functions, like if you have a lambda functions of 100 lines, it's like, I mean, very good time that when you pause and think that you perhaps should split or you shouldn't have it as a lambda function. And how long? There is like, I heard an advice, use common sense, but it's a bad advice. My advice would be use static analysis tools and practices and establish practices in companies. So because for one company, for one project, 100 line is a super long stuff, for another is another number. So just rely on the tooling here, please. And the last bullet here, and I have an example. So use less lambda functions that are assigned to local variables. So on the left for me, right for you side, I guess, here the code written with the style where all functions we are using here are the like pointers to the free function somewhere on top in the anonymous namespace and whatnot. And then on the another side, we have pretty much the same example, but all of this stuff are lambda functions, and they're assigned to local variables and then reused here. This, I tried to compact this example to fit the slide. Just imagine if each of those lambdas has like 2-3 lines of code, more lines of code. When you start reading it, top down as a regular developer, you just first read this, second read this, second read this, and only here you get into the point where the business logic of your function is implemented. That can create significant cognitive load, and it can be super confusing for you. There are other pros of like not using this. Before we come to that points, I just want to tell that again, that can be like vary based on the standards of your code, how long the function can be, what you allow for lambdas and whatnot. So it's not like universal stuff, but again, if there are a lot of lambda assigned to local variable, it can hurt the readability and maintainability of your solution. Just think of it. And in general, I would say use more free functions, like instead of perhaps lambda functions. Because the first thing, it's like straightforward. You already have small steps with names. They already named, they're already here. It's easy to reuse across the translation unit, or if you want to put it into namespace details or another modular interface, you can reuse it more widely. And the same for testing. It's quite easy to test small, simple bricks. You can just, again, put it into details, namespace, and then test, expose and test. Very good. You don't even need to have, like, these friend classes for your classes that you use for testing. I hope you're not doing this. But anyway. So another tip and trick, how many of you are familiar with bind back, bind front function? Okay, not that many. And this stuff you usually use if you already have a function, and this function perhaps used in many places, and this function already have different signature, and using lambdas is super cumbersome. And I will show you how it's used. But first of all, bind back and front, the available standard library. If it's not here, you can take it from ranges v3 or from other third-party libraries. It's not the big issue. But there are not many people familiar with bind back front, so I have this slide with the description. Imagine that we have a function to add two numbers, two ints. Then we have the std bind back. What we do, we pass this function add to the bind back, and then we have this number, so 1, for instance. It means that bind back will return another function that can be called of the single argument, and this one will be bound to this one, to the b, to the second argument. So how you can call it now? That's add 1 with 2, and that will return 3, because now it's a new function that can be invoked of a single argument, which is rather cool. So, and here, there's also interesting stuff. I have function to increment. Say to increment this a, I'm mutating a, not returning it. It's just for example here. So then I'm adding something. Then I have bind front function. And what it does like pretty much the same as bind back, but it bound arguments in the front of functions. So this variable a will be bound to this particular a, so to the first one. It's bound front, and it also returns another function. And what's important here, using studref for references or cref for const references, because all of your arguments you pass, they should be preserved in the capture list or tuple or something, and it would be notoriously hard to preserve the reference directly. So it will not compile if you do not wrap it with ref. And now you can invoke it with inc2, and you need to pass in only this one, and then a will be just to this initialized with 0. So and we add in it, and it's 2. Any questions how bind back front works so far? No, because I have something scary on the next slide, I believe. This is a possible implementation of bind back. And I mean, not necessarily fully correct one, but it just to explain how it works in more details. So suppose we have a function here, then we have the arguments. We want to bound to the back of this function. What we do here, we preserve all of those arguments here in the capture list. If you have older C++, you can use forward as a tuple, and then you preserve a function itself. And what you return a new function. This returns a new lambda. And when this lambda will be invoked, you have of the remaining arguments, you invoke f, you pass the remaining arguments, and you pass what was bound back. So that's how it works. And the difference between back and front will be the difference between all of this. We basically will put bound here, the bound arguments. So just a swap in places. And this is very... this was about a question about forwarding and stuff. So in this one, I believe, right? In this part, the answer is this is just an example implementation. So yeah, you can have it, and most likely you should forward the arguments. So, but yeah, regarding this implementation, I wrote it no test, no constraints check, pretty much nothing, just to show how it might work. So that we need to preserve arguments, preserve function, and then we return other functions and invoked over this stuff. So that's how bindback can be implemented. And now we go to more practical example. So where this all stuff can be useful for you. Imagine that you have function, because all monadic operations, they do accept like a single argument, like this is what's passed is either error or the value type. And if you have function that's used in many places with different signatures that accepts more arguments, that's where you need to bind back or front. In this case, we transform this add layout prefix function that invoked of 2 arguments originally to the function that works of the single argument, and we assume that we have just the string error. So that's how it can be used. We bound something, like say the literal here, and then it will be invoked altogether. And imagine that in real project you have functions where you need to bound like 3, 4, 5 stuff. You can use lambda function interchangeably. It will not be longer. It will like be pretty much the same, but it can be much more noisy in terms of syntax. Though this one is controversial, it's a matter of preferences and the best practices you establish for your project. But I would recommend to give bindback a try. And yeah, here in the title I want to point out that we have our own implementation of bindback, and that's why it's another namespace. It's our own standard library in our project. So that's another tip. It's rather interesting. So at the beginning, you want to make all your functions return either expected or optional, even if it's not strictly required, even if it's redundant. Here I have some example functions that remove from layout by iterator. So we just erasing from the Windows stack, we erasing from the Windows map, they were just put by IDs. And then even if this function fails, even nothing erased, we don't care. But we still return expected here and return default constructed stuff. It's basically void. Why do we do that? Because that would be easy to change from the beginning. And we do not have standard support something pure or some other concepts unless we use another third-party library. So it's very handy. And I would suggest to go for this redundancy, just in sake of better code readability and to make these things around easy. When you pass in values around, and especially many values, and you want to perhaps avoid binds back and some other many stuff, how many of you familiar with tuples, pairs, and other algebraic stuff? So yeah, oh, good. So, and this is, if you consist to tuple the collection of the object of different types. So there's a tuple of 3 objects, and you can make it like this. So in this function, we creating components to be reused in QML later, like in the C++ what we create, and then it will be invoked and reused. So what we have file name and view. That's some indicator. And then we create all of this stuff. But for the next steps, for finalizing, for putting some default properties and things, we might need to have context, component, and view named as an universal ID. So what we do, we simply create a tuple out of it, pass it to the next stage, and of course the next functions should accept the same tuple. Then we use structural binding to take all of this stuff and can work with this. If you have only 2 objects, then it's good. You can use pair, or you can use tuple. And you don't need to create extra structures. You can define everything in place. You can have even a small alias for it. And you can easily pass several objects between functions. Very good stuff. Utilize this one. Another thing I promise to remind, do not forget about transform error function. That's super useful. You usually have many third-party libraries. You have your own different libraries with different kind of error. You don't want perhaps to have too much overhead, but you want to transform error between this stuff. You might need to just take the second part of unexpected transform error to another, then pass it. you might need to pass additional context, even in scope of the same translation unit. Imagine that you need to do some cleanups. You might pass some context to clean up and the expected object as a part of new error type, and then transform it to the normal one at the end. You might need to amend the existing error, add prefix, add something else. So transform error is like perhaps super useful function. So do not forget about it, please. And that's the thing. So at the very beginning, I mentioned that we are assuming that you do not have third-party libraries, but you most likely will be having this, and this is good stuff. Many things are already implemented. Many things are well tested. What you need to take is just grab, reuse, and be happy with all of this stuff. So the important thing that if you explore those, you can get an inspiration for some tips, tricks. You can learn more about functional word. You already, as I mentioned, have well-tested solution. The libraries like just open TL expected code, open ranges with 3 code, open CPP lift code, and some other libraries. Just explore. Even standard library, if your toolchain supported, just double control click on the IDE and see how stud optional say implemented. It cannot be easy at the beginning, especially if you're talking about standard library, but still, that's super useful. And with this, I strongly believe this was my first slide. Thank you, guys. And we have 8 minutes for questions. You can ask now or after that. Yeah.
Hi, thank you for the talk. I have some performance consideration for using these operations. So if you have chained call and then, how many copies of the object and expected you will have at the end?
Well, that's a question. That's a very interesting question. First of all, as I mentioned, you need to measure everything because most of the thing that you might have copied will be elided, optimized by compiler. There is RVO, NRVO, there is stuff that moved between the steps. There is a value semantic. Some steps can be omitted. So my universal question, or like answer to a question, I do not know, because it would be different based on the project you have and the situation you have. It can be close to 0 overhead for some cases. It can be close to 0 overhead in other cases. So if you perhaps have some sort of high latency apps or whatever, you should consider not using this. But again, I do not know because it highly varies of the projects. So.
Thank you.
Yeah.
Thank you for the talk. I think there's an option to receive, to expectify your result that could be useful for functions from third parties which doesn't return expected. It's not part of the standard as far as I know, but it's something which you could add. Mm-hmm. Right? You're familiar with that? I'm not sure if you want to.
Yeah. I totally agree. That's a good comment. You can utilize expected in many ways, like for composability as well. So, yeah. Any other questions? Or if not, have a great evening, guys. Done.